guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, today we are here to witness another beautiful launch from the Canaveral, Florida, if I pronounced it all right. And yep, it is an Atlas V launch, which is the first Atlas V launch of this year. Atlas V, the most reliable rocket right now. I mean, 100% success rate. Yeah, 100% success rate for this vehicle. And today, it will be launching very important payload to the orbit, and the payload is from the US Space Force. So the payload is very important and crucial for the United States. So yes, we need a reliable launch vehicle for a precise orbital insertion. So hi everyone, hi Pival, hi Rajesh Singh, hi Game Aniator, hi Nebula, hi Max, hi John, hi Slunico, hi Wildflower, and I am very excited for this launch. Atlas V launches are always beautiful to see, and yep. So today the vehicle which is launching is the Atlas V rocket. So we should be having a close look at this rocket. I mean, first of all, this Atlas V has this 400 series and this 500 series, which we can see here. And the difference between these two series is this fairing. We can see the fairing for the 400 is a smaller one, and the for 500 we can see it is a big one. And why does it go with a bigger one in 500 series? I'll tell you. I will tell you the reason why we have these two different configurations. So without any further ado, we can have a look at the rocket. So this is the rocket which you should be seeing here, a cutout section of the rocket, which is this is the best diagram to understand the all the characteristics of this rocket. So first of all, this is the core stage we have here. This is the core stage which we can see, and this has, you can see, liquid, obviously this core stage is a liquid fueled, and it is carrying liquid oxygen and liquid RP1, liquid oxygen, and RP1 as its fuel, and it is also has this solid rocket boosters attached on the side. So talking about this, let me just zoom in a bit and we can see here. So you can see that there is a fuel line which is going in from the upper tank, which is an this liquid oxygen tank. And this liquid oxygen tank is going, the fuel from this is going into the engine, which is to be done, right? But the Atlas V initially was not designed to fly with solid rocket boosters. So that's why the fuel line which you can see here, it is actually running from outside. And now this creates a difficult opportunity for attaching the solid rocket boosters, because this fuel line runs from the outside and is not running from the inside. So therefore, when you attach the solid rocket boosters on this Atlas V rocket, it creates an unsymmetrical configuration. And if you have seen the if you have played the KSP, if we attach the booster in an unsymmetrical configuration, how bad that could be, because there is an unsymmetrical thrust. The center of thrust is not at the center of the engine, but we have the center of thrust in between these two, liquid and the solid, which causes some problems. So uh, you know to counter that, because this is a thing which we will see today, although today we will see some symmetrical launch, because the configuration today we will be launching, as you can see, they will be launching is a 4-2-1 configuration, which simply means a 4-meter fairing. 4-1 stands for 4-meter fairing, two solid rocket boosters, and one upper stage engine. So 4-2-1, that's how the thing looks like. And yeah, that is the thing. The engine it runs on is the RD-180 engine, which is a thing to be discussed about, and I will surely tell you how things are there with this engine. It is a pretty good engine, I must say. And then yeah, so first stage consists of a core stage and two solid rocket boosters. So that is the thing, and solid rocket boosters are the pretty standard one. Now talking about the second stage, so this second stage is the USP, you can say, for the ULA because this Centaur second stage is known for its reliability, for precision, precise insertion in the orbit, and better handling of the payload. So this is the most advanced upper stage which has been developed till now, and that is why NASA trust ULA more than SpaceX, because first of all they have a pretty good track record. It's a very old company, and second of all, this Centaur upper stage is very capable for very precise insertion burns. We need precise insertion burns for like going to moon, Mars and beyond. So if any 1 meter per second of delta V goes here and there, then there is a pretty big problem in the trajectories when you go further beyond in the solar system. So that's why in those cases this is very reliable choice. So, and yes, the second stage has the RL-10 engine, and this RL-10 engine is a the thing which we are waiting for to see today. Okay, if you haven't understood from the diagram here, we have a cutout section also. So yeah, this is the core stage, this is the RD-180 engine, then sorry, this is the core stage, this is the RD-180 engine and the boosters, and then the interstage, the Centaur upper stage, and then the spacecraft and the 4-meter fairing. Yeah, so talking about the 4-meter and 5-meter fairing, what is the difference between these two? So you can see here in the 400 series, there is only 3 solid rocket boosters attached here, right? And for the 500, it can go to around 5 solid rocket boosters. So this first of all, you need to know this Centaur upper stage is very sensitive, as in it's a very lightweight upper stage, and to make it lightweight, its fuel tank is literally comparable to a balloon. As Tori Bruno himself says that the Centaur upper stage is having fuel tanks of balloon fuel tanks. He referred them to as balloon fuel tanks, and he literally compares it to a dime. He says that it is even thinner than a dime. The fuel tanks are even thinner than a dime, and hence it can simply just if you don't pressurize this Centaur upper stage when it is just standing on the ground also, will crush in its own weight, because it won't be able to handle that much of weight. So that is how that much is the structural integrity for this Centaur upper stage. Although it's a, you can think of it like it must be weak or something like that, but no, it performs very well in vacuum, which is from where it is need to be performed, and in the launch configuration also, since it is pressurized, so it can handle those vibrations and g forces. So that is the case. But when you attach these solid rocket boosters and keep on increasing the numbers beyond 3, like 4 or 5, then there is a problem with the Centaur stage. Then the Centaur stage will not be able to support the high G loads which will occur from the uh, solid rocket boosters, and hence you can see here this 5-meter fairing is used, because this 5-meter fairing is used to absorb some of the, not absorb as such, but distribute some of the G loads coming from the engines to the fairing, and we have a much less impact on the Centaur stage. That's why we can see it like this. So yeah, this is the difference. Now talking about this unsymmetrical booster configuration, we can see it from here. This is a very good slide, or you can say not slide but PDF. Come on, where you can see the configuration which is actually used in these rockets. So normal day rockets use these kind of configuration. Normal two solid rocket boosters attached in a line with the engines, and pointing towards the center of the engines if we cross the line here. But this is the Vulcan rocket configuration which we can see here. But if I go on to the Atlas V, you can see here, first of all, let me just zoom in a bit more. We can see this a line going out of the rocket. This is the fuel line which I mentioned. And because of that, we can see how the solid rocket boosters are actually arranged in this rocket. We can see that for a 4-to-1 configuration which is being launched today, the if we just take a line from these two solid rocket booster, it does not go very well into the center. We can see it's a bit of not at the center. Still it's a two solid rocket booster, so symmetrical we can say. But when it goes to 4-3-1, which we can see here, now the things start becoming interesting, because here it is an unsymmetrical configuration in which the thrust from this section is more than this, and hence when this happens, to counter this effect, the engines actually start at a gimbaled position. So we have more thrust here. So to counter that, the engines will move in this direction, will apply in thrust in this direction, and yeah, so that's how the things will work to counter that. And the payload capacity, talking about the payload capacity for today's launch, it is around 6.8 tons to geotransfer orbit, which it is going today. So yeah, it's a pretty heavy rocket too, in just 4-to-1 configuration. Okay, now we can have a look at the engines which we can talk about. First of all, thank you so much, Roger, for that $20. Really appreciate the support, man. Thank you so much for your kindness. Okay, yes, the countdown is real. We are going in for today's launch. And how are you, everyone? Sneaky US military satellite. Yes, it is. Um, okay, what are they launching? I'll be telling you about everything. So guys, just stay here, just witness the things which is happening today. Okay, I will cover each and every aspect of today's launch. So, and thank you so much for the appreciation, everyone, guys. So first of all, the picture which you are seeing is the Atlas hot fire test, and the engine which you are seeing are the RD-180 engines. These are the RD-180 engines. Now, what is special about these engines? First of all, just admire the look of the rocket engines when they fire up, and comes into its full thrust. These rocket engines are, a treat to watch. This is, the best thing which I can ever witness in up close, if I get the chance to witness. Obviously, we can't see it very close because of for the safety reasons, but still, someday, some time, if I can get a look at these engines when it is firing up from somewhat a safer distance, but a closer look like this, I'll be very flattered, you can say, to be precise. So yeah, the rocket engines are RD-180, and this is the coolest rocket engines developed. So the coolest and the most powerful rocket engine till now which has been developed is you tell me, guys, the the most powerful liquid fueled engine developed till now, what is that? Tell me that, first of all. uh Yeah, I'm just waiting. I will. Okay, I'm waiting for the answer, but you answer that, and I'll tell you the correct answer also. So, okay. Now I have to. Yeah. So this is the RD-180 engine, and we can see that there is something written in Russian here. And yes, people are there. Answers are coming in the chat. It's the Saturn V's F1 engines. Yep, 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 yep. You missed the question. I said, what is the most powerful liquid fueled engine developed till date? And people are, I know people will say the F1 engine, but the answer is not F1 engine. But surprisingly, the answer is the RD-170 engine developed by Soviets. And they used that engine in their Energia rocket, which actually, flew the Buran shuttle. That was a, Russian space shuttle, Russian version of the space shuttle. So, yeah. The RD-170 engine is the most powerful rocket engine ever developed because the thrust of the Saturn V's F1 engine was around 7 meganewtons, and for RD-170 it was around 8 meganewtons. And how does it able to achieve that? I will tell you that. But uh, this engine which you are right now seeing in front of you, this is the RD-180 engine, and the difference between RD-170 and RD-180 is simply the half. I know it does not work like that, but for better understanding, you can imagine it. If you cut the RD-170 engine into half, you get RD-180 engine. And what is unique about this engine is, and why does it able to produce so much of thrust, is this only, that it is, you can, from the look of the rocket, you must be, seeing that, or you must be feeling that this is a two engine design. But here, that is what is deceiving for this rocket engine. It is not a two rocket engine which you are seeing here. These are not the two rocket engine. It's a single rocket engine and two combustion chambers. So why am I saying it? That because this middle part which you are seeing here is the single turbo pump, which actually feeds the fuel to both of the combustion chamber, in this also and this also. So this is a single rocket engines with two nozzles and two combustion chamber. And if you are not able to get from the model, I have the technical diagram also for you to see. Here you can see this is the turbo pumps, which we can see the main turbine here, and it powers the both combustion chambers here in the nozzle and the combustion chamber. No more turbo pump, just a single turbo pump and a pre-burner, which we can see here. So one turbo pump powers the both of the combustion chamber. Now if you ask me what is the usefulness of this configuration, or you ask me what um, what is the use of this, and does it exist in first of all. So actually the thing is, this rocket engine, when you have this configuration, when one turbo pump and two combustion chambers, this actually allows the rocket engine to divide the thrust. Okay, and it does not impart most of the load on that single throat of the pressure for the chamber. So there is one thing called chamber pressure in the combustion chamber, and you can have a limit to that, right? And if you are flowing so much of fuel to a certain combustion chamber, and that chamber, basically the pressure could exceed. So Soviets came with a solution for that problem, and the solution was this, in which they distributed the pressure in two combustion chambers, and hence you can have that less pressure handling chamber, but you can get optimal performance from the engine. And this is one of the reason why it is uh, powerful. The second reason is that it uses a stage combustion cycle for the thrust, for providing a thrust. So stage combustion cycle is obviously highly efficient than a gas generator cycle used by the F1's engine. So yeah, the RD-170 is the most powerful liquid fuel engine ever flown, and this is the RD-180. You can say when you RD-170 actually has four combustion chamber, single turbo pump and a four combustion chamber, and then here we have this for RD-180, one single and two combustion chamber. No, I just have to confirm. I don't remember right now, but for RD 170, it was two combustions, two turbo pumps, and four chambers. I have to confirm that. But for the RD 1, it is single turbo pump and two combustion chambers. So yeah, guys, do you even like the info which I share with you? I don't know whether I should be doing all this or not, or whether you are more into having a look at the rocket itself. Uh, Used to watch those Saturn V launches back in the 60s. I know, Max. That those were, the most epic thing to watch then. Okay, moving on. Uh, this is the in front of you is the RL-10 engine. Now, this is also a very interesting rocket engine. This rocket engine is used as the Centaur upper stage. Uh, Yes, especially when there is a MS paint drawings. Okay, cool. Actually, I'm trying. I will surely improve the coverage in future, in which, if possible, you could see some animations also. But right now, it will go like this. Okay, so this is a vacuum engine, RL-10 engine. This is the Centaur. This will support the Centaur upper stage, and as I said before, this is the USP for ULA, the most precise rocket engine, the most capable upper stage which has been ever developed till now, and this is the most capable and the most efficient also. First of all, this engine runs on liquid oxygen, liquid hydrogen, which is the most optimal rocket fuel to run in space. And because of its high ISP, you can get out of the hydrogen and oxygen. And then if I move on to the next image, this this you must be wondering, what is this? So first of all, uh, this is a rocket engine, the RL-10 rocket engine, which you can see from a regular perspective. This is the regular size of it, but there is a special property for this RL-10 engine which greatly increases the efficiency, and that is this. You can actually see the picture which you just saw right now was till here only, but we can see something coming out of this engine, and this is the property of this engine because it has the extendable rocket nozzle. This actually just fits inside, it just compresses and fit in here only, in this position only, to be capable to fit in the interstage of the Atlas V. And once in the orbit, and or the once the core stage separates, the this extendable nozzle extends itself and becomes a very big nozzle, which is a key aspect to, as in why it is able to achieve such a high ISP of around 453 seconds, because of this thing, this the more this extendable rocket nozzle. And if you are wondering how does this increases efficiency, so this is a property of you know um, um, rocket engines working in vacuum of space, which states that if you have the that the outside pressure, the environment pressure, when it is equal to the exhaust pressure coming out of the rocket, then the rocket is the most efficient. So practically speaking, in vacuum of space, there is zero atmospheric pressure, right? So we need to have zero pressure when it is coming out of the nozzle. So that's why we're trying to extend the nozzle as much as possible, so that the area expands. Once the area expands, the pressure decreases, and you get to have the optimal performance. So that is the thing. Okay, now talking about the payload. Oops. First of Before going on to the payload, this is the mission profile which we have to see here, which we can see obviously. First of all, the liftoff will happen, then the stage separation will happen with the booster separating first. then the main engine will cut off for the boost for the second first core stage. Then we'll have the stage separation. Then we will have the second stage start one, which we can see here, MES1 Centaur main engine start one, and then the fairing will jettison. Okay, then we have something called EZ3 deployment and EZ4 deployment just after the main engine cutoff one. So we can see that the main engine starts at around 4 minutes and cutoffs at around 15 minutes. So it's a pretty long burn, and this long burn actually places it in this orbit. It's not a very highly elliptical orbit, but still it's an elliptical orbit, which we can see here. And once it is in this orbit, it deploys two additional uh, you can say sats satellites, which are going into the going today with the military satellite. I'll talk about what is that satellite also, but right now just remember that those will be deployed. Then again the main engine will start. Once those are deployed, the main engine will start, which will actually push the orbit from this to the final orbit, which we can see here. And then finally, once it is in the once it has deployed the uh, satellite, then it will start the engine again at this position to deorbit. And then finally the main engine cutoff will happen once it has deorbited. And before letting it enter into the atmosphere, they do this maneuver, or you can say do this thing. They do a blow down, which simply means they basically just let all the remaining fuel out of the rocket so that it does not create a problem when it enters the atmosphere. So that is the blow down thing which they do. Okay, so that is the thing. Okay, let me see if we do have the coverage right now. Nope, don't have. I didn't know I will be able to make it happen for so long. Okay, when it comes to rocket science, that thing happens. Okay, so the thing which you are right now seeing is the payload for the military, for the US Space Force, which is this satellite, which is the SBIRS satellite, as they say. And if you ask me, what is the thing with this satellite? First of all, what is the full form of SBIRS? It stands for Space Based Infrared System. It will be actually, it's a network of satellite and hosted payloads in the geosynchronous Earth orbit and highly elliptical Earth orbit, which utilize scanning and steering infrared sensors to provide early missile warning and defense capabilities to the US Space Force and Missile System Center. So this is the, this work of the satellite. It is a defense satellite, as they say. It can detect if there is a, missile being fired at US or so, but I hope that does not happen. But if that happens, it can give an early warning so that they can be ready. Okay, so this is the fifth satellite going up, and they plan to have around 6 satellites. So next satellite will be launched in around next year on the Atlas V rocket. And yeah, that is pretty much about this satellite actually. So yes, it actually provides some defense capabilities, enhances those defense capabilities of US. Looks a pretty good satellite also. And obviously it we from the size we can see that it must be having some optics also, because just the infrared system for such a big satellite, it does not make any sense for me, at least. It will surely have some reconnaissance properties also. I am suspecting that. So let's see. Now, I was also talking about the those two other satellites also, which are going to the space today, right? And these are the EZ3, EZ4, which is nothing actually. If I can pull up that, where is it? Okay. Flight profile. Yeah. If you can see here, this there they have this set these two small dots, you know, coming out of the rocket from the aft section from here. And this is the capability of the Centaur. You can say that it can host a 12U CubeSat, uh, almost four of them it can host if necessary. Okay, 12U CubeSats. And where it can host these the CubeSats, it's the aft section of the rocket engine. And the container, you can say the container or the avionics and the payload adapter for the CubeSats look like this. These are the EZ3 and EZ4, which will house the two CubeSats for the US, again for the US Space Force. And basically this is the TDO3 and TDO4, as they say, which is a technology demonstration orbiter, which will actually have some those which will provide those experimental data that can be used to provide and improve future missions. So those CubeSats will not have any propulsion as such, and hence will host some of the experiments in it. And um, they will provide that initial data to build upon a larger satellite. So these are the technological demonstrations, smaller CubeSats, which Centaur upper stage will also carry. This is a pretty good thing to see. Now, talking about the visibility map, here we have the visibility map for today's launch. Okay. If I were okay, so this is the visibility map for today's, which we can see. And from the map only we can see this won't be visible for to most of the public. And if you happen to see this launch, and if you want to see this launch today, the best place to view this launch is from the beach side. And if you can travel there, well and good. But you know, we know what time is it, and we should not be going outside. But still, if you live nearby, you can come to the beach, and you will be able to see the rocket launch. So again, that flight path is similar. At second circle, which we can see, you will be able to see the rocket at around t plus 60 seconds. And then it just goes on and goes on. And when it comes actually onto the land at around at for the if you live around the near the beach, then at t plus 90 seconds you will be able to see the rocket. And for the people living on the east side of the Florida, coast of the Florida, uh, you can see the launch, which you can see here at for t plus 30 60 t plus 90 seconds to 7 t plus 210 seconds. If you live on the east coast, you will be able to see the launch there, and if it is not cloudy there. So this is the thing we have today. Now just a sec, there is one thing which is needed to be done right now. Let me see if we have any update for today's launch. Right now, though, everything is looking good for today's launch. Countdown is continuing smoothly. Anomaly channel is quiet as of now. And we are right now 90% go for the launch, which means the probability of launch today is 90% in accordance to the weather. And other than that, no as such updates. So yeah. Can we get some live views of the rocket? Yes, Rajesh Singh. Once the webcast starts, we will get the views. I don't think so it has started yet, but we can wait for it to start. But in the meanwhile, I do have something for you to have the live views of the rocket. Oh, here you go. Shout out to 321 Launch for providing these beautiful live views of the rocket. And obviously, the rocket is not very much visible from here, but we can, see the rocket being fueled right now. We can see those uh, cryogenic gases coming out of the rocket. And yeah, the um, evident payload fairing, the 4-meter payload pointing fairing. Hmm. Okay. So now, if you have any other questions, guys, you can ask me. And if you want to, you know, if you like the information which I share, please go and hit that like button. Subscribe if you are new to this channel. I will keep on providing those awesome information for you all. So, yep. Mm-hmm. Waiting for them to, yes, we do have the live stream now from the ULA themselves, although we are waiting for them to start. Once they start, I'll switch over to that. You can, what else is need to be discussed today? Well, as such, we don't need anything more right now. We have already discussed everything. And yeah, we just have to wait for the live coverage to begin. We are T minus 22 minutes until the liftoff. Everything is looking good. And yesterday there was an anomaly which happened, and because of that the launch was called off. And basically what happened there was that the chill down of liquid oxygen before they load that liquid oxygen into the centaur upper stage, there was some faulty sensor which was not temperature sensor, basically, which was not detecting good temperature for it to be loaded into the centaur upper stage. So that was a thing which happened there. Since the launch window is not very big for this launch, only a 40-minute launch window, so they were not able to figure out that problem at that very moment. So yeah, otherwise the cooling system was working perfectly fine. Only the sensor was not working, and now they have replaced it, and we are right now go for the launch. Hi Pudge Gaming, how are you? Uh, what about the live stream? Still waiting to for them to come live. Okay, so talking about this ULA right now. So ULA actually is pretty much going forward for the Vulcan rocket, which is in right now in development. Okay. So this Vulcan rocket which ULA is developing is, you can say, is a very unified launch vehicle, because it can act as Atlas V also, and it can act as a Delta 4 Heavy also. So a single rocket which is capable of doing both a lighter payloads to the orbit as well as the heavier payloads to the orbit. So that is the case, and that the engine which it will be using for the core stage will be developed by Blue Origin, and those will be BE4 engines, if I'm not. And it will run on uh, liquid oxygen and methane. So that is very good to see. So yes, and these rocket engines or Atlas V comes from Russia, And yes, they have this contract which Russia has signed, and they will be providing the those engines to the Atlas V for some time. But um, contract is also coming to an end soon. So they need rocket, they need engines, and hence they contacted Blue Origin for their BE4 engines, and we'll have to see that.
Launch vehicle is ready to launch.
We have ignition.
You have permission to launch.
1, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute, and we have an indication of spacecraft separation.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the 5th Space-Based Infrared System satellite for the United States Space Force. Good afternoon and welcome to Cape Canaveral Space Force Station in Florida. I'm Dylan Rice, Systems Test Engineer, Launch Conductor, and the host of this afternoon's broadcast. Liftoff is set for 1:31 p.m. and we have a 40-minute launch window for today's launch attempt. A few seconds from now, the count will enter a planned 15-minute hold. We have 2 planned holds in our 7.5-hour launch count today. These holds give our team additional time to resolve any issues prior to entering terminal count. However, at this time, the team is not working any issues and we are proceeding towards an on-time liftoff. Early in today's show, we'll hear from Systems Engineer Tim Pika about getting today's mission ready for flight. Then stay tuned after liftoff to follow mission events leading to spacecraft separation and to learn more about the SBIRS GEO 5 satellite from a recent conversation I had with Lockheed Martin's Melanie Young. And Lieutenant Bryce Leader and Lieutenant Adam Farrell will join me here in the ASOC to talk more about this mission and the important work done by the SBIRS constellation of satellites. In addition to watching the webcast, you can also follow live mission progress at ulalaunch.com.
Okay. So I am hoping
Jessica
to
Williams,
see
weather officer for Space Launch Delta 45, recently briefed the team. Here are the numbers. The probability of violating launch constraints is less than 10%. Ground winds are 17 to 22 knots out of the east, and the temperature is 80 degrees Fahrenheit. With that forecast, the weather is within launch commit criteria and looks favorable for our planned T0 of 1:31 p.m. Eastern Time. Today's flight will fly an easterly heading away from Cape Canaveral. In addition to the 5th SBIRS satellite, today's flight also includes 2 multi-manifest satellites. Let's take a look at what else we can expect to see.
5,
so
4,
this will be the mission
3,
profile.
2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket.
I must say that ULA has this beautiful coverage, at least for their launches. They have these HD cameras all over.
2 solid rocket boosters ignite to generate more than 1.5 million pounds, or nearly 6.7 million newtons of thrust, to lift the rocket on its way towards a geosynchronous transfer orbit. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path, while minimizing the dynamic pressure the vehicle experiences during flight. The Atlas V reaches Mach 1, the speed of sound, at 47 seconds. Following burnout, the 2 SRBs are jettisoned at 2 minutes 9 seconds to shed their weight. Within the next 2 minutes of first stage flight, the Atlas V rocket will more than triple its velocity. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 700 pounds, or 320 kilograms per second. With propellant levels depleted, the booster engine shuts down at 4 minutes 10 seconds, having reached space. The Atlas V is now traveling nearly 12,500 miles, or 20,000 kilometers per hour, located 73 miles, or 118 kilometers in altitude, and 235 miles, or 378 kilometers downrange. 6 seconds later, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs a little more than 7% of what it did at liftoff. 10 seconds later, Centaur's RL-10C11 main engine ignites for the first burn. Fueled by liquid hydrogen and liquid oxygen, this burn by the newest and higher performing variant of the RL-10 engine powers Centaur to orbital velocity. During ascent, the SBIRS satellite is protected inside a 4-meter diameter payload fairing at 4 minutes 34 seconds. Once the vehicle has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. At 15 minutes 6 seconds, cutoff of the Centaur main engine, or MECO-1, occurs. 31 seconds later, EZ-3 is deployed. EZ-3 and EZ-4 are fully integrated flight systems attached to the aft end of the Centaur. Each of these systems contains a 12U canister containing small multi-manifest satellites sponsored by the United States Air Force Academy that will help in creating critical capabilities that support the warfighter. Following EZ-3 deployment, the Centaur performs a 180-degree roll and deploys EZ-4 at 16 minutes 25 seconds. At 31 minutes 6 seconds, the Centaur main engine is restarted. Following a nearly 3.5-minute burn, powered flight is complete, and the Centaur main engine shuts down. Centaur and the spacecraft will coast for the next 8 minutes. At 42 minutes 46 seconds, Centaur releases the 5th SBIRS GEO satellite for the United States Space Force, providing early missile warning detection for the United States.
So here we have it, guys. The most beautiful launch vehicle, and see the views today and see the weather today. This is so beautiful, man. When this will lift off, we'll see what do we have here.
7th Atlas V launch and ULA's 144th mission. Built in Decatur, Alabama and Harlingen, Texas, Atlas V is comprised of a common core booster powered by an NPO Energomash RD-180 engine, equipped with 2 Aerojet Rocketdyne solid rocket boosters, and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C11 engine and equipped with a 4-meter diameter payload fairing. Events began with lifting the 107-foot or 33-meter booster onto the mobile launch platform at the vertical integration facility. Then the SRBs were mated to the booster. After the satellite was encapsulated inside the payload fairing on April 30th, it was transported to the vertical integration facility on May 7th, where it was mated to the Atlas V rocket at Complex 41. An Atlas V launch countdown begins with moving the rocket from the VIF to the pad. 6 components are used for the 20-minute, 1/3 mile trip to the pad. The MLP, which weighs about 2 million pounds, supports the rocket and contains air conditioning, electrical, and commodities lines. Undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move. The payload van provides spacecraft communications. The ground van provides support for the rocket. At the rear of the convoy is an environmental control system providing air conditioning to the payload and rocket. Trackmobiles power the nearly 3 million pound convoy. The Atlas V rocket stands 194 feet, or about 59 meters tall, and weighs just under 1 million pounds, or nearly 431,000 kilograms, fully fueled.
Man, I
ULA's
can't
Atlas V
believe
is
my
launching the
eyes
5th
right
dedicated
now.
satellite in the space-based infrared system. Built by Lockheed Martin, this is the first launch of a satellite using the company's modernized LM-2100 combat bus, an enhanced space vehicle that provides even greater resiliency and cyber hardening against growing threats, as well as improved spacecraft power, propulsion, and electronics. SBIRS GEO 5 is equipped with powerful scanning and steering surveillance sensors
Wow.
to protect our nation 24/7. These infrared sensors collect data that allow the U.S. military to detect missile launches, support ballistic missile defense, expand technical intelligence gathering, and bolster situational awareness on the battlefield. Also riding on today's Atlas V are 2 multi-manifest satellite vehicles, EZ-3 and EZ-4, which contain 2 technology demonstration orbiters known as TDO-3 and 4. These satellites, sponsored by the Department of Astronautics at the U.S. Air Force Academy, will ultimately be used to create capabilities that assist the nation's warfighters in performing their critical missions. Led by the Mission Manifest Office, this multi-organizational design, analysis, manufacture, test, and integration effort was performed within just 9 months. Getting a rocket and satellite prepared for launch require a lot of work coming together at the right time. Mission Integration Systems Engineer Tim Pica tells us how it's done.
Primarily, my focus is on defining all of the interface requirements to take the payload and put it onto our Atlas rocket. That includes defining all of the hardware, environmental, launch site requirements, and then on the tail end of the mission, right around now, is where we're finishing all of the verifications tied to ensuring that we meet all of the requirements to get both SBIRS and Centaur to end of mission successfully. The work really starts about 2 or sometimes even more years before a launch, where we get a set of requirements from the payload customer, and then from there it's an ongoing process to work with both the payload manufacturer as well as the government teams to kind of make sure all of the requirements are defined for all those interfaces between our rocket and the payload. ULA does have a history of launching SBIRS missions. We've done 4 to date, starting back in 2011. What's unique about SBIRS 5 is that Lockheed Martin redesigned the satellite. Specifically, certain thermally sensitive components are in new locations. In the case of SBIRS 5, we do consider it a short coast mission, meaning it's only about 43 minutes from the time we launch to the time we separate. So it did pose some unique challenges for us to ensure that we could keep all of those components on the satellite within their thermal constraints. With SBIRS, we do have the 2 additional CubeSats that we consider auxiliary payloads to the mission. So our primary goal is to get SBIRS where it needs to be successfully, but we also have in work with the auxiliary payload team, which is a different customer, to define their requirements and make sure we get those payloads where they need to be. One of the challenges with this is you need to make sure that the requirements for the secondary payloads don't induce extra risk onto the primary payload. So that really is the exact same process we go through with the primary payloads, but with the added step of ensuring that nothing we're going to do with the secondary payloads is going to increase risk to successfully completing the SBIRS mission.
And the views are so awesome for this launch. I mean, wow, man. I can just
The artwork on the
view this thing and see this thing whole day.
SBIRS GEO satellite. Additionally, an eagle, the mascot for SBIRS, is front and center in its claws to represent this missile warning mission. We also see 5 red beams emanating from the center star to represent the SBIRS infrared capability, as well as this, the 5th GEO satellite. Finally, the SBIRS motto, always vigilant, is imprinted on the missile.
See this beauty. This will actually take off into the sky, and we are getting
We remain in the
so
planned
clear
15-minute
views.
hold as we continue toward liftoff. In a few moments, launch conductor Scott Barney will poll the launch team for the final go to pick up the countdown. 29 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling.
LCS redline monitor. Go. Roger, step 150 is now verified. Roger.
We'll listen to the famous go for the launch for this rocket, which is very satisfying to hear when they say go for the launch.
LC, net 1.
LDN1.
Yeah, we are close, very close to our topping. Recommend extending the hold.
I copy.
LC switch
Please
will remain
extend
in
the
a
hold.
ready position.
Okay. Going on, waiting for the checks
Third
to
launch conductor
complete.
Scott Barney recommended to the launch director that we extend our built-in hold for just a few minutes while the team monitors a propellant conditioning issue. So we
Okay.
will stand by and await an updated T0.
So we have a hold here, guys. We have a hold here, T-4 minutes and holding, and it's not a built-in hold. They have got some thing for today. Let me see and update you as in what is the reason for the hold, as in actually they said something about the propulsion, the fuels conditioning systems. We'll see. We just see that here.
LC Lux 1.
Go, Lux 1.
Fogo suppressor charge is complete.
Roger. And LOX 1 LC, your status on step 850.
Atlas Apollo 2 at flight level.
Roger. And with that, all steps are complete prior to the status check.
LC STD.
Go.
Spacecraft is configured for launch.
Roger.
Okay.
And RLM LC. Go ahead. I'll again verify red line monitor and event table in a correct configuration for terminal count. Verified. Roger. Okay, all personnel stand by for the status check. And we'll get a new T0.
Sure. Waiting for the new T0. So it was a quick check which they performed, and I don't think so it will prevent them from launching this today. As we heard, the vehicle is configured for the launch, and we will see. We'll just have to see.
With all the required activities prior to terminal count now reported complete, the team will choose a new T0 and we'll get moving here momentarily.
0 of 1737.
1737 Zulu. Roger. RC, LC, note 1.
RC.
Please coordinate a new T0, 1737 Zulu.
1737 Zulu in work.
ALC, set the clock for a T0, 1737 Zulu.
Roger.
Okay, the clock is set
Copy.
at 1737. Are they correcting the config for LOX Wildflower ask? Whatever they had to correct, they have corrected. There was some
LC, ALC.
Go.
Countdown clock has been set for a new T0 of 1737.
Roger.
So actually they were having some issue with the conditioning of the fuel, but okay, actually I don't think so there was a problem. The only thing which I can think of is that they were just verifying the
LC,
data.
RC, net 1. Go RC. New T0 is approved. Roger. Okay, all personnel, we have an approved T0 for 1737 Zulu. LC switch to the ready position. All steps are complete prior to the status check.
And as you just heard, the clocks are now set for our new T0 of 1737. The range has approved the new T0 and the team is now ready to proceed with countdown. Launch conductor Scott Barney will resume his activities and conduct the poll for terminal count in just over 1 minute.
See, the people are there with
8 minutes.
8A. Where is it launching from? It is launching from Cape Canaveral, and right now you just enjoy the views, man. These views and their sound is so cool right here. Wow. Okay, so Wildflower asks, okay, I have a legitimate question. What is this stopping other nations from using an endothermic propulsion?
-7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operations support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer. Go. Vehicle System Engineer. Go. Anomaly Chief.
Go.
Range Coordinator.
Clear to proceed.
Launch Director.
Launch vehicle is ready to launch.
Mission Director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1737 Zulu.
Verified.
So there
Polling
we
is
have
complete.
it.
The ULA launch team and the Space Force mission director are go for launch. From T-minus 4 minutes until launch, you'll be listening to Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team call out that Atlas liquid oxygen topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activities. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, Atlas tanks will be verified to flight pressures, followed by a verification of Centaur tank pressures. A final status check of Atlas, Centaur, and SBIRS GEO 5 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Patrick Moore providing launch vehicle ascent data.
STD, this is LC. Please re-verify spacecraft remains configured for launch.
Verified.
Roger. All steps are complete prior to terminal count.
All steps are complete. We are go for the launch. Everything is looking good, and the vehicle and the views today are looking so good. I'm just hoping to see a good launch today and a good show too. Okay, so do you know, guys, that ULA has this amazing property of adjusting the trajectory, or you can say the
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
ULA is this
On my mark,
amazing.
the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
Cool. Okay.
The countdown clock
3:55.
has resumed, and we are go for launch at 1:37 p.m. Eastern Time.
So actually, they update the weather on this thing on the rocket according to, I mean, the upper level winds, the ground level winds are very, updated at the very last moment so that it can have the accurate trajectory as much as possible. And that is one of the reason for its success and success to the most precise orbit. So yeah, I am just waiting for this thing to come to its full power and go into the space. This is looking so cool. The onboard cams, which we will see there also during the flight, everything is looking good.
T-minus 3 minutes.
The Atlas is go
Atlas
for
takes the flight pressure.
launch. Now just
2
listening
minutes,
the
50 seconds.
mission control.
FTS internal.
You can see the liquid oxygen is secured now. No more topping off. Just release in pressure buildup if any. Wow. Those birds. This is the silence of a beast arriving right now. T
159.
2 minutes and counting, guys.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
Hey,
140.
Launch enabled.
137.
FTS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
this is happening, guys. I'm getting so
120.
excited.
OCU's armed.
FCS count started.
T minus 1 minute and 10 seconds in counting.
110.
Vent valves locked.
T minus 1 minute.
Rock.
Wow.
Range status.
Range green.
Okay, we are go for the liftoff, guys. Range is green. No problem for the liftoff. T minus 48 seconds. Just sit back and relax and enjoy the beautiful show showcased
40
by the
seconds.
mighty Atlas V.
Step 3.
$25.
Status check. Go Atlas.
Go Centaur.
Go SBIRS.
T minus 15 seconds. 12.
T minus
11.
10, 9, 8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, and liftoff. Liftoff, the United Launch Alliance Atlas V rocket, the
Whoa.
5th space-based infrared system satellite for the United States Space Force.
This is the most epic liftoff I've ever witnessed.
Now 15 seconds into flight. Tues gone to closed loop control. Engine operating parameters continue to look good.
Wow, man.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Vehicle's now completing the pitch over program. Body rates look good. Seeing good chamber pressure on both SRBs.
And we
And
have the
RD-180
mark
now
effects.
beginning the throttle bucket. Engine response looks good. And now passing through Mach 1. Atlas V is now supersonic and max Q, maximum dynamic pressure.
This is actually
Body rates
looking
continue to look good through the boost phase.
full CGI, but this is for
Vehicle's
real.
now
guys.
throttling back up slightly. Engine response continues to look good. Chamber pressure on both SRBs continue to look good.
The most
Now passing
beautiful
1 minute
launch.
10 seconds into flight. Atlas is now 10 miles in altitude, 4.5 miles downrange distance, traveling at 2,000 miles per hour. 1 minute 20 seconds into flight, standing by for SRB burnout shortly. Body rates continue to look good. Chamber pressure on the SRB is now tailing off. And we have burnout on both SRBs. Atlas will hold on to the SRBs for an additional 39 seconds before jettison. RD-180 is throttled back up to full thrust. Engine response looks good.
This is to ensure that they fall in a safer location.
Now passing 1 minute 50 seconds into flight. Body rates continue to look good throughout the boost phase. And the Atlas V now weighs 1/2 of its liftoff weight.
Wow, man.
And standing by for SRB jettison shortly.
And there we have
And we
it.
have good indication of separation of both SRBs. Now just under 2 minutes remaining in the booster phase of flight. Vehicle's gone to closed loop steering, seeing a slight correction in the body rates, now damping out nicely.
Closed loop simply means that it is now
RD-180 engine operating parameters continue to look good.
adjusting the
RD-180
trajectory
throttling down slightly now as expected.
as per the flight trajectory. Previously it was not doing that.
2 minutes 40 seconds into flight. Atlas is now 39 miles in altitude, 68 miles downrange distance, traveling at 5,400 miles per hour. And the Centaur reaction control system is now pressurizing the flight levels. System response looks good.
Man,
Now coming up on 3 minutes into flight. RD-180 pump speeds and injector pressures continue to look good. Body rates continue to look good. Now about 1 minute remaining until booster engine cutoff.
wow. I have just forgotten about every
Pump speeds and injector
complexity
pressures on the RD-180 continue to look good throughout the boost phase.
it is facing right now. Just enjoying all the beautiful views we are getting from this rocket.
3 minutes 30 seconds into flight. Atlas is now 56 miles in altitude, 160 miles downrange distance, traveling at 9,000 miles per hour. And RD-180 is now throttling to maintain a constant 5G acceleration limit. RD-180 responses look good.
I simply don't have words.
And Centaur's begun the boost phase chill down sequence.
Down has begun for it to come.
RD-180 now going to 4.6G throttle limiting, standing by for BECO. And we have BECO booster engine cutoff, standing by for stage set. And we have good indication of stage separation.
He
We have boost out on the RL-10, standing by for ignition.
And we have the ignition.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
And obviously you can't see the plume because it...
And we have good indication of payload fairing jettison. This first burn of today's mission will last approximately 10 minutes 30 seconds.
We have the payload fairing
RL-10 engine
jettison.
operating parameters look good. Body rates have damped out nicely from the startup transients.
We can see the trajectory right now.
And the RCS system has begun the initial thruster firings for system thermal conditioning.
Data
Just over
here.
5 minutes now remaining in, or 5 minutes now into flight.
What's with that gas exhaust? That is nothing but that RCS firing, and you can't see the exhaust because it is liquid hydrogen and liquid oxygen.
RL-10 chamber pressure looks good.
Does not have a it has a clear exhaust.
This is Atlas Mission Control at T plus 5 minutes 20 seconds. Patrick Moore just confirmed successful completion of the early phase of today's flight, and all systems continue to operate nominally.
See that? Do you see that?
The mission is currently in the first Centaur engine burn. Our next event, Centaur main engine cutoff, will occur in approximately 10 minutes. Lockheed Martin builds the SBIRS satellites for the U.S. Space Force. Here's a video highlighting the power of these satellites.
Don't want video, man. Okay. So did you guys see that? The wobble in the engine nozzle, and that was because the wobble was happening in the extended nozzle of the RL-10. So yeah, it was bound to happen. That is not very good handler of those vibrations, but it does the job. So yeah. I meant the gas plume on over the right from that pipe. That is wildflower. That is the RCS firing, the reaction control system, which is used to. That is nothing but the cold liquid nitrogen gas, which we have for Falcon 9. That is the thing we have here, the reaction control system firing. So yeah, fairing halves. Exactly. We were able to see those fairing halves.
Last week, I had the opportunity to talk with Lockheed Martin's Melanie Young about the incredible capabilities SBIRS 5 brings to the constellation. Let's take a look at our conversation.
And thank you so much for that 5. Really appreciate it, man.
Yeah, thanks. I'm really excited to be here. I am a systems engineer for Lockheed Martin Space, and I've worked in the U.S. Space Force's Space-Based Infrared System, or SBIRS program, for 14 years.
Wow, that's awesome. For our audiences, can you tell us more about what SBIRS is and what SBIRS does?
Yeah, SBIRS is a critical system for the U.S. Space Force and for our national defense. It has a constellation of SBIRS satellites that continuously protect our nation and armed forces. The SBIRS satellites are equipped with scanning and steering surveillance sensors. They detect missile launches and support ballistic missile defense, expand technical intelligence gathering, and bolster our situational awareness on the battlefield. On the ground side, there's a ground station that receives and processes tons of SBIRS data. The SBIRS operators take that data and use it to make reports for defense
launch
and
today was
intelligence and
way
civil
beautiful.
applications. And SBIRS GEO 5 is the latest satellite to join the SBIRS constellation.
So the SBIRS program is very important to our national defense. You mentioned that this is SBIRS 5. We've launched 4 SBIRS birds in the past. Can you tell us what's different about SBIRS 5 compared to the previous satellites?
Yeah, we're very excited about SBIRS GEO 5. It's the most advanced and resilient SBIRS satellite that Lockheed Martin has built to date. It was built in about 5 years, and it's the first military space satellite built on our LM-2100 combat bus. So that is the version of Lockheed Martin's modernized modular LM-2100 space vehicle. It has greatly enhanced resiliency. That LM-2100 bus is an internally funded multi-year modernization initiative that has greater resiliency and cyber hardening, enhanced spacecraft power and propulsion and electronics, It's got a lot of processing and features as well, where we have common components that streamline manufacturing. And then it's got a flexible design so that you can put on future modernized sensor suites. So this is a huge step toward achieving, this resilient missile warning that is ultimately going to follow on in next gen OPIR Block 0.
Wow, that sounds really important. That's really a significant upgrade compared to the previous birds that we've launched. I know for me, working in the industry, I find it really rewarding to participate in some of the launches that we do, both national defense and some of the science missions. What's it mean to you to work on the SBIRS program?
Yeah, I'm really proud to be a part of the SBIRS program, supporting our national defense. And SBIRS plays such an incredibly important role in protecting our country and our armed forces. And I'm really proud to be a part of this team.
Awesome. Well, hey, thanks for talking to me today. We recently received some sad news that a mutual teammate, Bill Levinson, had passed away. I know that Bill had a tremendous career with Lockheed Martin. He's also a longtime ULA employee when we formed ULA in 2006. He worked in our chief engineer's office, both in the major development as well as the chief engineer for the Delta program and then the Atlas program. He contributed in numerous ways to all of our programs.
Yeah, we thank Bill for his many years of service to the industry, and he will be missed.
Well, thanks again for joining me today, Melanie. It was really great speaking with you.
Yeah, thank you.
Once operational,
Yay.
the Space Delta IV team at Buckley Air Force Base in Colorado will control the SBIRS GEO 5 satellite. Let's take a look at a short video message.
Hi, I'm Captain Hannah Ritter.
And I'm Second Lieutenant Nicholas.
Okay, so we have yes, Wonton. It's insane how a few years ago we weren't launching anything. Now there are like every other day we have one launch, and this has to increase day by day with to enable us to have those multi-planetary dreams come true. So this has to happen, and the main thing which I'm very much looking forward to is the nuclear propulsion. I'm again saying the same thing, and I will say it again after some time also in the multiple streams, because that is a thing for the future. Until and unless we have a nuclear propulsion system in place which provides adequate thrust and has enormous amount of delta V, we won't be able to expand ourselves in further away the solar system.
Satellite are currently located over the Atlantic Ocean, west of Africa. Our next event, first Centaur main engine cutoff, or MECO 1, is coming up in a few minutes, followed by deployment of EZ3 and EZ4. Once again, here's Patrick Moore.
Temperatures as expected, and telemetry quality continues to look good.
We
Now
don't
coming up
have
on
the
12 minutes into
velocity
flight.
as such here, but we do have the perigee and the apogee. The perigee
Approximately
still
3 minutes now remaining in the burn.
is still inside the earth. It will come outside. It's still in minus, so that means still inside the earth, coming out of the earth slowly.
Centaur is now 125 miles in altitude, 2,200 miles downrange distance, traveling at 17,000 miles per hour.
Okay, so Naman Bajpai says, what are your thoughts on the least
12 minutes,
turnover
30
time?
seconds into flight.
I would say the turnover time until and unless they become like a turnover time of
Chamber
an
pressure
aircraft.
on the RL-10 has continued to look stable throughout this burn.
I would definitely want it to that level. So yeah, SpaceX is working on it, and hopefully with this Starship vehicle, we will be able to see
Now passing
that in
13 minutes
action.
into flight.
So these
And just over 2 minutes now remaining in the burn. Centaur systems all continue to operate nominally.
and these, those short bursts you see coming out from the side of the rocket are actually used to control the attitude of this vehicle, which attitude is nothing but the orientation. It makes sure that the satellite and the rocket are facing the right direction. So yeah, that is the case. And you will once this thing shuts down, the engine shuts down, you will see that the EZ3 and EZ4 will be deployed. Those are nothing but the small CubeSats which are
Propellant
named as
utilization system is continuing to control appropriately in the closed loop mode. Body rates remain stable.
so yeah. I was saying those EZ3, EZ4 is nothing but the TDO, which is the Technological Demonstration Orbiter, which will house the experiments which US Space Force can, um, run and hence acquire data. And then once they have the proper data out of it, they can scale it to a bigger version, to a bigger satellite in future. So yeah, right now we have a CubeSat. The future, maybe out of the whatever data that generates, we can expect some bigger satellite also. Do you know exactly how far out it will go? It will basically
And we're seeing
targeting
good pressures on helium and hydrogen storage bottles.
geosynchronous target transfer orbit. So you can expect it to
And
be
standing by for engine cutoff shortly. And we have MECO main engine cutoff. Body rates look good. Centaur now engaging 4S settling as expected.
37,000 kilometers. Yeah. The apoapse could be around 37,000 kilometers right now.
And standing by for CubeSat deployment shortly.
Yeah. Attitude systems working continuously to orient the spacecraft, keep the orientation of the spacecraft in the right direction. The EZ3, here we go. We have one
And
deployment.
we have good indication of separation of the TDO3 CubeSat from the aft bulkhead carrier.
Is rotating actually, that's why the payload is not rotating, but
Centaur now rolling 180 degrees in preparation for separation of the TDO4 CubeSat.
Exactly.
And roll rate is now damping out. And the roll is completed, standing by for separation of TDO4.
Yes, this CubeSat is not a relay. This is
And
an
we have good indication
experimental.
of separation of the TDO4 CubeSat from the aft bulkhead carrier.
There we go. This is an
Now 16
experimental
minutes, 30
CubeSat,
seconds into flight.
which will house some experiments for the US Space Force so that they can, run data out of it and maybe expand the normal experiment, smaller experiment to a bigger scale into a full-fledged satellite.
I'm joined now by Lieutenant Bryce Leader, EZ3 and EZ4 Program Manager. Lieutenant, thanks for joining me. We just saw the successful deployment of EZ3 and EZ4. Congratulations.
Hey, thanks so much. It's such an exciting event to watch. I mean, fantastic launch to watch, fantastic separation. Really, just thanks to our partners here, ULA and Parsons, for all the hard work they put in so far. So it's looking good. So thanks again.
Excellent. As EZ3 and EZ4 Program Manager, what's your role?
Yeah, it's a great question. So I want to point out I'm a Space Force program manager now, which is kind of a big deal for me. Just transitioned recently, but I'm based out of the Mission Manifest office, which is a subset of SMC out of Los Angeles Air Force Base. And I know that's kind of a mouthful, but pretty much what we do is we try and maximize the capability on the launch vehicle through multi-manifesting. And we've done this on 3 missions so far.
Who built TDO 3 and 4?
Yeah, so TDO 3 and 4 was built by DNet Integration and Design. It's a small company out of Denver, Colorado. One thing I do want to point out, though, is one of the partnerships we had on this mission was with United States Air Force Academy. It was the first time working with them, and it was a great experience. Really hope we can do it again in the future here.
I bet that was an incredible experience for the cadets.
Oh, it was so great. We actually got to get them out here for the EZ3 and EZ4 matchmate. So I actually got to watch them bolt on the flight system. So that's really exciting. And as an Air Force Academy alumni myself, I couldn't be more excited to see the next generation of officers, Air Force and Space Force coming out.
Oh yeah, and
go Falcons.
talking about that Tianzhou 2 launch, it will be streamed. I will try my best to get one stream out of it. So maybe not official, but unofficial streams could happen. So I'll try my best to get that for you, for all of you. So yeah.
Or the specific satellites that are integrated into the EZ3 and 4 flight system.
What's different from EZ3 and EZ4 compared to previous missions?
Yeah, so I love that you asked this question because it lets us brag a little bit about our capabilities in the Mission Manifest office. So the first two missions we had are very similar to the configuration we have for EZ3 and 4. The main difference, though, is that we actually have twice the amount of satellites on this mission compared to our previous two missions, which were HF5 and HF6. Another fun fact is this is actually our second time doing a U.S. Space Force mission. So it's awesome that we're building our capability as we expand into the Space Force as well.
So has the National Security Space Launch Program ever deployed these EZSats prior to the primary anchor payload?
Yes, so actually on that HF5 and HF6 mission that I mentioned before, we deployed both of those satellites before the primary payload as well. And why that's important is because certain satellites have specific requirements that our warfighters need. So ultimately, we're getting critical capabilities to our warfighter when and where they need it.
So what's next for the Mission Manifest office?
Well, we're pretty busy here, Dylan. We got quite a few missions coming up. But one I want to highlight is a partnership with NASA on the Landsat 9 observatory mission. We're actually populating an entire SBIRS ring that's going to have up to 13 satellites on it.
Wow.
Yeah, so that's launching out of the West Coast in September here. So we're really looking forward to that one.
Well, thanks, Lieutenant. We appreciate the details and your perspective on this very interesting program. I'm sure you're anxious to get back to following EZ3 and EZ4. But if you'd like to stay with me for just a few minutes, we have something coming up that you might appreciate. Because this mission is so important to our national security and to the safety of our troops, we want to honor our military by sharing photos of service members that were contributed by our Twitter followers. Each of these photos is a person that is near and dear to their family and friends. We thank them for their service. We thank you for your service as well. And also thanks for joining me. Let's take a look at that package.
Good enough to like this.
What a great tribute. And thanks to all, again, for that have served and continue to serve our country. Transporting the Space Force's SBIRS GEO 5 satellite to the launch site here at Cape Canaveral required collaboration with the Air Force. Let's take a look at an interview with one of the pilots.
The space mission is essential to everything the military does, whether it be GPS, whether it be in the missile detection, whether it be really mapping anything. So the C-5 is a special aircraft because it can fit outsized cargo, meaning the design of the plane allows it to hold things that most normal planes wouldn't usually be able to hold. Most planes need palletized cargo, whereas we can fit larger cargo such as helicopters, tanks, and satellites. So yeah, this is a special mission because we only have two C-5s capable of doing that mission, and we don't do it very often, so it's a privilege to be able to contribute to the space mission. So in order to prepare for these space missions, we have to, as an aircrew, be very cautious and prepare much more thoroughly in regards to turbulence, in regards to weather, routing, making sure that no hazards are going to be in the way that might potentially damage the satellite or the container that it's in. It could damage the satellite, so we need to be very cautious on especially important missions. We even have another C-5 going in front of the C-5 carrying the satellite just to scout out the air ahead of us if there's any turbulence or weather that we need to avoid. And we will be trying our best to make this landing as smooth as possible in order to prevent it from getting damaged. So yeah, the loadmasters are essential in this. They're the ones who basically run everything to do with the cargo. They are the most, I would call them the most essential part of the C-5, or of the satellite and space mission, just because it takes usually up to a day, 2 days in order to safely and correctly put these containers on. So the amount of expertise that it takes our loadmasters and our engineers in order to get these things on safely and correctly is astounding. Working with the civilian community and the space community in order to move these satellites is just a great experience and a different experience than what we're used to working with military only.
Now we are entering the
This
dark
is
side
Atlas
of the
Mission
Earth.
Control at T plus 25 minutes and 20 seconds. We are a few minutes away from the restart of the Centaur main engine. Let's go back to Patrick Moore.
Centaur systems all continuing to operate nominally.
So
And vehicle is continuing the PTC roll, and we are
before
continuing to
the ignition, you will see that these RCS thrusters are right now also firing. But before the ignition, they need to fire so that they can act as ullage for the fuel tank. Ullage is nothing but, you know, when in space, you are in space, you are in free fall, as I already told you. And at that time, there is no as such, you know, net force acting on you, and hence the fuel can travel inside the fuel tank as blobs, and you want your fuel to be at the bottom of the tank so that it can go to the engines and engine can start, but that does not happen when you are in space. So to make that happen, to make sure that all the fuel is at the bottom of the tank, we have this the RCS thrusters sometimes firing up just before the ignition, so that it gives a certain some sort of forward push, which enables the fuel to come at the back side of the fuel tank. And once they are at the back side, they will be able to, you know, go to the engine, and once the engine is started, there is a net force. So always the fuel will be collected at the back side of the fuel tank and will be pushing it to the engine. So yeah, that's how the things work.
now passing 27 minutes into flight. Centaur systems all continuing to operate nominally throughout this coast. Vehicle is continuing the PTC roll.
And
vehicle body rates remain stable. Storage bottle and tank pressures continue to look good. Main vehicle battery temperatures and voltages also look good.
Oh, John Wilson, that's a good thing. Okay.
Yes, loop temp.
And right now we are waiting for the second burn to start, and this burn will basically raise the apoapse to a geosynchronous transfer orbit. So yes, this burn is like right now they are in a kind of a circular orbit, and once they reach the, you know, the perigee, also they will again fire up the engine so that they can raise the apogee to the height of around 37,000 kilometers. So yeah.
To conclude the PTC roll in preparation for the next burn. And we are seeing the roll come down to conclude the PTC. And Centaur now adjusting its attitude.
This slowly raising the apogee also with this RCS burns, making sure that it can have that certain sort push in the prograde direction. And I think it is actually spin stabilizing the rocket if it is spinning, right?
Now passing 29 minutes into flight. And in a little over 2 minutes, the Centaur engine will ignite to begin the second burn of today's mission. 23 seconds prior to ignition, the RL-10 will begin the fuel and oxidizer pre-start sequence. This burn should last approximately 3 minutes and 20 seconds.
Exactly.
And body rates have all milled out now in preparation for the burn.
Right now
and
we
Centaur
can
now engaging 100% 4S settling.
Okay, so we can see the increase in the apogee as well as perigee here, which is happening because of those thrusters firing.
And just under 1 minute now remaining until engine restart. Tank pressures are increasing in preparation for the burn.
And again, reminding this Centaur fuel tanks are referred to as balloon tanks because the fuel tank's thickness is thinner than a dime. So it is very lightweight and a very capable upper stage, which you are
And we
right
have
now
fuel
seeing.
pre-start on the RL-10. "15 minutes until main engine start. And we have LOX pre-start. Standing by for ignition. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
There we have it, guys. Again, the main engine right now will increase
As
the
Patrick
APOAPS
Moore
to
just reported, the Centaur main engine has
37,000.
been restarted for a second engine burn. This burn will last approximately 3 more minutes. The Atlas V continues to travel in a southeasterly direction. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent where the trajectory will switch to an easterly heading. Separation of the SBIRS GEO 5 satellite will occur over the Indian Ocean east of Madagascar. Let's go back to Patrick Moore.
Chamber pressure throughout the burn. Vehicle autopilot is controlling well, seeing good stable body rates in the closed loop control. PU system operation looks good.
The apogee number race will increase as the time will pass by. Farther away from the Earth, when apogee is further away from the Earth, you require less fuel to raise the APOAPS. That's how the things work.
And 2 minutes now remaining in the burn. Body rates remain stable, and RL-10 engine operating parameters continue to look good throughout this burn. And about 100 seconds now remaining in the burn.
Although this RL-10 engine has,
and seeing a good constant acceleration of the vehicle during this burn.
Does not have that
PU
big
system
amount of
operation
thrust,
continues to look nominal.
but still it's a
And
very
we are
capable
continuing
one.
to see periodic thruster activity on the RCS system as expected. Loop temperature staying close to bottle temps. 1 minute now remaining in the burn.
— 16,000 kilometers in altitude, and the number is increasing slowly and steadily, but it will
Body rates
raise.
continue to look stable as vehicle is controlling in closed loop.
Let's see what will be the final altitude for the apogee. And thank you so much, Mick, sorry.
Now 30 seconds remaining in the burn.
For the appreciation. Glad to hear that.
Centaur systems all continue to look good throughout this burn. PU's gone to open loop in preparation for MECO and standing by for main engine cutoff shortly. And we have MECO main engine cutoff.
We have it. 35,000 kilometers. Close to
RCS is now at 100% settling, as expected. System response looks good. And Centaur is now turning to the separation attitude.
This is Atlas Mission Control at T plus 34 minutes and 55 seconds. We just heard the call for successful second main engine cutoff. Our final mark event in today's show, spacecraft separation, will occur in approximately 12 minutes.
Actually, this this separation of this sometimes take time because first of all, you don't get that proper ground station connection which you want, so you wait for that
Joining me
ground
now is
station
Lieutenant
to
Adam
come
Farah.
at
Lieutenant.
the right position, and then you deploy the spacecraft so that you can monitor it.
Program manager for the 5th and 6th SBIRS satellites, what are your responsibilities? What's your average day look like?
Yeah, great question. So I'm an acquisitions officer in the Air Force, and I'm part of the systems engineering, integration, and test integrated product team, or IPT, for GEO SBIRS 5 and 6. So with this, my responsibilities, I manage risk associated with the program, I review earned value management data, I plan the early on-orbit test campaign, and I contribute to the launch readiness review process. And with these responsibilities, my day can get pretty busy. An average day, I reach out to individual IPTs with regards to risk. I review contractor data. I attend virtual meetings, and then I report my findings or assessments to upper leadership. But I really enjoy my work, and I really enjoy working with the contractor and government team that I work with. And it's been awesome, and I think we've done a great job adapting in this all telework COVID environment.
Oh, it's been a very challenging year, no doubt.
For everyone.
So we've heard a lot about the SBIRS satellite today. Can you give us some additional background on the SBIRS capabilities and the development?
Yeah, absolutely. So the Defense Support Program, or DSP, was the original missile warning capability for the United States. The first satellite was launched in 1970, and the last satellite was launched in 2007. And in the span, there were a total of 23 DSP satellites put into constellation. Like I said earlier, this was the original missile warning capability fielded by the United States, and this is where SBIRS fits in. So SBIRS was designed to replace the DSP constellation, and now in the missile warning constellation, we have DSP satellites, we have HEO, or highly elliptical orbit satellites, and we have GEO, or geosynchronous Earth orbit satellites. Now, in regards to evolution, and with GEOs 1 through 4, and then 5 and 6. So 1 and 4 were built identical to each other, and 5 and 6 are functional equivalents of each other. However, they both have a design change in the bus, as well as minor design changes to account for material and parts obsolescence. And I think this just shows how our capabilities are evolving to help our military defend from the national security threats that we have.
So how does the SBIRS program benefit the warfighters on the ground?
Yeah, great question. I think that's really important that gets answered, because ultimately our program is here to support the troops and to defend the nation. And in today's global environment, the number of threats is greater than ever, and these threats are evolving at a very fast pace. So it's important that the military and our capabilities, like missile detection, missile deterrence on a global scale, are it's important that these are where they are and where we need them to be. And that's where, again, SBIRS fits in. So we provide that global, persistent infrared surveillance capability that the troops on the front line, as well as our nation, need to defend against this ever-changing 21st century threat environment. And again, or not again, but I just want to bring in a real-world situation where this capability helped, or actually shows how we help troops on the front line. So in January of 2020, Iran attacked Al-Assad Air Base in Iraq, where U.S. troops are stationed, and space operators were able to, using SBIRS capabilities, were able to detect the threat, warn U.S. troops who are on the direct path of the missile. Due to the early detection, no U.S. troops were harmed or killed, and I think, again, this just shows how our capabilities are actually helping the troops on the front line.
Yeah, an absolutely critical capability,
exactly.
no doubt.
Very important.
So obviously, liftoff is super exciting to see. We're just a couple minutes away now from spacecraft separation. What are you feeling right now?
Yeah, so that was awesome. That was the first lift or launch that I've ever been a part of. And I just want to say congratulations to everyone who has gotten this far and worked with the team. And I know the mission isn't over, but still getting here is such an accomplishment. Watching everything come together and now being moments away from spacecraft separation is amazing. And however, this is only the beginning of the SBIRS mission. So once spacecraft separation happens, then we need to make sure we get in our desired orbit, as well as make sure the satellite is functioning properly. So we start with a series of liquid apogee engine burns to get into our circularized orbit. And then we turn on the satellite, turn on the payload, and make sure that, again, the systems are functioning properly. And once all of this happens and we're in our desired orbit and in the constellation, then that's when the SBIRS mission actually begins. Now, another reason why I'm really excited and why everyone's super excited is because this is the first time in the Space and Missile Systems Center history that Space Force acquisitions officers have sat on console for day of launch. So for SMC, for the Space Force, for the nation, and for our program, it's just a remarkable accomplishment to get to this point, and I couldn't be happier. And I know everyone on our team feels that same way.
Well, thanks for sharing your perspective. It,
Yeah.
it sounds like you have a really cool job, and appreciate you talking with us here as we
Yeah.
get closer to SBIRS separation. Hopefully, you can hang out with me here in the booth for just a couple more minutes.
Yeah, don't worry, I'm not going anywhere.
Awesome. This is Atlas Mission Control at T plus 41 minutes. We're approaching spacecraft separation here in just a few minutes. Let's go back to Patrick Moore for the last call of the afternoon.
Okay, finally, we are heading towards the separation of the satellite. And
Now just over 90 seconds remaining until spacecraft sep.
Okay.
Centaur systems all continue to look good.
Once it is, separated, it will coast towards the apoapse of the satellite, then turn on its engine and then circularize at apoapse, because you can see that the perigee, which is the lowest point in the orbit, is still at 924 kilometers. It needs to be around 35,000 kilometers. So that's when it will be.
And vehicle is now beginning to arrest its roll in preparation for the
Geosynchronous
separation. Now 1 minute remaining until spacecraft
orbit.
sep.
That is the thing here.
And roll rate is nulled out.
Once it has, fired up its engine and made the orbit circular, it will deploy solar panels. Solar panels will be deployed, I think.
For spacecraft sep.
Yes. Wait for the separation. Wait for it. And
20 seconds to separation. Centaur now spinning up in preparation for separation, standing by for spacecraft sep. And we have good indication of separation of the SBIRS GEO 5 spacecraft.
And the mission is completed. Well, his mission is done. SBIRS satellite office has work to do now.
And following spacecraft separation, we have approximately a 37.5 minutes coast prior to MES 3.
That's a deorbit burn. So finally,
Congratulations to the dedicated teams across the nation on a successful launch and delivery of SBIRS GEO Flight-5 to orbit. And Lieutenant, congratulations to you and your team as well on a successful mission. Thanks for joining me today.
Yeah, thank you. Such an awesome day, and go SBIRS GEO Flight-5.
My thanks also to Patrick Moore for his participation in this afternoon's broadcast. You can continue to follow the mission live on ulalaunch.com or follow us on social media. We'll leave you now with one final look at the liftoff of SBIRS GEO Flight-5 at 1:37 p.m. Eastern today.
yes, we
On behalf of
want
the
to
entire
see
launch team,
that.
I'm Dylan Rice. Thank you for joining us and have a great afternoon. T-minus 10, 9, 8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, and liftoff. Liftoff, the United Launch Alliance Atlas V rocket with the 5th space-based infrared system satellite for the United States Space Force.
Man, the liftoff was so beautiful.
Now 15 seconds into flight. Tues gone to closed loop control. Engine operating parameters continue to look good.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Wow, man. This is what we call a launch here. That was the most epic launch I have ever seen for the Atlas V. I can truly say that. Okay, so now what do we have here? Uh, so you just saw a successful liftoff of the Atlas V rocket, and that too a very beautiful liftoff to enjoy. Um, now the next thing, the next big thing I should say, coming up will be the China space station, another module of the space station launch. So uh, the space station will be, the module is a cargo module named as Tianzhou 2, and it is scheduled for around in just 2 days from now, less than 2 days I should say. And we will have a look at it. We will again see what do we have in store for us for that. And yeah, we will hang out and discuss space rocket science. So guys, did you like today's coverage or not? Just type in the chat. If you want any other um, improvement as such, any other thing, please type in all your suggestions. Otherwise, everything was good for today. If you want to follow me or support me in what I do, you can always subscribe this channel and give it a like to the stream basically, and maybe become a Patreon. Link is there in the description. There is a high probability or the Chinese rocket will go out of control on descent again, and likely each time thereafter. Wildflower, to your the thing which you are saying is not quite right here, because the rocket which will be launching the module will be the Long March 7 rocket, and it does not have that problem of rocket part uh, you know having an uncontrolled descent. It is not having that problem. The only rocket which has that problem is the Long March 5B rocket, and yes, that rocket has two more launches scheduled in 2022 and 2023, so we'll see what do we have there. Okay, thank you so much, Rof Gaming. Brilliant coverage again. Rocket Gyan, awesome stream again. Appreciate it, man. Now let us see what do we have on Twitter, if we have any other updates. We all do every time. Okay, so we do have this image which has come up. This is the SN15 Raptor engines after the flight, and the most epic thing about this photo is that you can see this photo was taken when the SN15 was still on the landing legs. So this was a very early photo, and just seeing at this uh, photo or picture, we can see that there is no as such wear and tear on the rocket from the outside as such. We don't know about the inside of course, but from the outside it does not look like a bit of a concern, although there are some parts looking rusty. I don't know whether they will change the Raptor engines for the SN15 reflight, or will they be flying with this rocket engine only? We'll have to see. Rather, right now the SN15 is on the launch mount, so that is a good news. And yes, this picture has been circulated. So yeah. And this was a picture taken from today's stream, I suppose, because it was having such a high quality stream, and we can see the mark effects when it is crossing the speed of the sound. The engines are looking good with the RP1 and locks burning in properly, and the solid rocket boosters always providing that extra little oomph to the initial part of the ascent. Bird away. Okay. And there we also have this OneWeb launch coming up on 27th of May, if I'm not wrong. And yes, we will see that too. And if you guys want, you can follow me on Twitter, guys. I actually tweet a lot of stuff about space and rocket science. You can surely tweet me out if you want. Using a different rocket than the last time, because that one is kind of notorious for that. I mean, see, this is SpaceX, headed by a man, which himself is very notorious. You can say that, right? Elon Musk. And we have seen in the past that SpaceX is very much capable of doing extraordinary things. And if SN15 flies again before even SN16 and they fly with the same engine, that would be a great thing to watch. And yes, somewhat a thing to, just have a sip of it. I mean, you can expect SpaceX to do these kind of things, obviously, but sometimes they just go out of their limits to achieve something. So yeah, that is the thing. Those engine bells look like they rusted fast. Is that the rust? Most probably. Wildflower. That happens because obviously the oxygen, liquid oxygen, is very rusty as such. It rusts the metal, and if when during the during when they throttle down the engine, they obviously adjust the concentration of the mixture of fuel, how much liquid oxygen and liquid methane is to be used, so that they have some kind of throttling ability. And sometimes that causes the rust because you have some uneven fuel mixture, maybe a bit of more oxygen in there. So yeah. Other than that, any other update? Okay, tell me what. Yeah, so it's Titan Tuesday. I was about to say, tell me what engine it is. We have seen it now. This rocket was also very beautiful to witness in its time. And we can obviously make the Kerbal version of it. Kerbal rocket parts, the stock rocket parts of Kerbal. This program actually has these uh, historical parts in it. So I think with that note, we can end today's stream. If you have any other questions, you can ask me. Otherwise, we can end the stream. Rocket Wildflower says that begs a serious question. If they oxidize that fast, how would this play out for the moon landings? Repeated use in space and potential Mars reuse landings liftoff. Okay. Part time says if it's titanium and then it's not rust. Yes, yes, exactly. The thing is, they see the sometimes these parts rust because the oxygen is, have that thing with it, that it is capable of rusting the parts. The titanium is. We have seen that SN15 has had some major update in their Raptor also, and Raptor had those green nozzles before they came. So many people speculated that green part of it is somewhat has a coating of titanium out of it. I don't remember, but some kind of titanium alloy or somewhat. And yeah, if I don't know. I'm not particularly sure whether that is a rust or not. But if it is a rust, then also there is no as such, a big problem, because we just want that the critical parts of the engines are not rusted. Maybe some parts here and there have occasionally rusted. That's okay, because they don't handle that much of pressure and structural loads. So maybe that is okay. But we don't want a rust in the turbo pumps. We don't want a rust in the chamber, the throat. Yes. And I don't think so as particular whether it is a rust or not, because SN15 had, I just remember that SN15 has those design changes, those major design changes. And I just remember, yes, there was some type of alloy coating, titanium alloy coating done on the nozzle. We'll have to see what particular thing that is. Thank you so much, Chris. Will you do a live for Tianzhou 2 launch 20th May? Yes, I will do. Actually, we are not expecting official live coverage of that event, but we may expect some unofficial ones. So I'll try my best to gather the best stream possible for you guys. Once if they fully rust over, the rust would actually protect the inner metal like a coating, but I'm just thinking out loud. Yes, no, no. The rust has this property. Some metals has this property that rust protect the inner metal, but like iron, it does not do much of a protection part of it. For aluminum, it does. For silicon also, we have this silicon oxide coating to prevent us from radiation. So yes, uh, that is also there. And but I don't think so if it is not aluminum as such or any other alloy which has this rust keeping sticking on the metal surface and not just flaking out like iron, uh, then only we can expect some protection. Otherwise we can't. We'll just expose a new layer of metal from behind. That's it. Why did the Starship Boys says, why did the Osiris Rex mission use one SRB on the Atlas V? That's a good question. First of all, this Atlas V is, capable of adjusting, handling, I should say, handling these unsymmetrical thrust on the engines, on the rocket, basically. When they actually use one SRB, the center of thrust actually changes, and yes, there could be some issues if the engine is not counteracting to counteract and provide a decent maintain that center of thrust in the middle. So yes, Atlas is capable of doing that. And to answer your question, why did it do that? See, I remember that Tori Bruno himself said, if I'm not wrong, that the Osiris Rex mission could have been successful without the SRB also. Okay, but they added this SRB so as to have some more delta V as its in error margin, and hence they will be able to precisely insert the Osiris Rex mission to its intended in the orbit, or Mars, or interstellar orbit, because we all know Osiris Rex was going to an asteroid, and those interplanetary or interstellar missions, interplanetary I should say, or what do we say, that space, is it interstellar, what? But yeah, the in the solar system, when the orbit comes out to the solar system, we need a very, very, very precise burn to actually make that insertion possible to its very accurate position. So yeah, that must answer your question. They need more delta V to have more margin of error. That's it. Oxide is the term, I think. Yes, part-time oxide. The aluminium oxide, the ferrous oxide, the silicon oxide, all these oxides. First of all, ferrous oxide does not work like that. Ferrous oxide is nothing but rust on the iron. Aluminium oxide does protect it. In copper also, the copper oxide protect it from again rusting. But I don't know what material they are using on that. Whether that, if that is the rust, is it protecting it or not? ferrous oxide or ferric oxide, that depends on whether it is FeO or Fe2O3. If I'm not wrong, ferric oxide is Fe2O3, ferrous is FeO. The difference is +2 and +3, Fe+3 and Fe+2. Yes. Mostly ferric oxide is the thing, the Fe2O3 is the thing which we call as rust, but FeO also can form in small uh, small quantities. You have a Discord server rocket? Can it's in the making, Starship Boy, and it will actually, I had to release it uh, in this week only, but this week was so busy for me, as in I had to stream so many launches, so I wasn't able to stream that launch that Discord server, but I am making it. Hopefully I'll be able to launch it soon. Cupric oxide is green, right? Is it cupric oxide or cuprous oxide again? Yes, it is green. The copper oxide is green. The copper oxide is green, but which one? UO or CuO3? Just a sec. Oh, copper oxide. Copper oxide is green. Going wrong. O3 is cupric oxide is green. Yeah, CuO is green. CO2O3, if I'm not wrong, is black. Okay. Uh, looking forward for the server. Yes. Okay. Finally. Some chemistry out there, right? What's funny is barely use my engineering degree whatsoever where I work, getting rusty, pun intended. See, yeah, that is the fact for most of the jobs today, wherein you don't require that engineering degree to, work at your intended job. But again, the thing is that you have to get your basics right, and engineering degree actually helps you do that. But I don't know. I'm not a very fond of those things, but still, it does. If you don't know anything, so it does provide some material at least to study. Otherwise, I don't think so. It's so much use. Okay. Uh, what else do we have in here? You can follow me on Twitter, guys. The link is in the description. I mostly tweet about these stuffs, and yeah. So this is something. Earth observation dash board hackathon. Okay. See that. Otherwise, I don't think so. We do have any other update, but yeah. Okay, so obviously, this is the rocket which I was talking about, which will carry the Tianzhou 2 cargo module to the China space station Tiangong 2. This is the Long March 7 rocket. We'll talk about it when that happens. So right now, the thing is that we had a beautiful liftoff today. We had a beautiful liftoff today, and we got those mark effect, those beautiful mark effects. Otherwise, everything. See, today's liftoff was a liftoff which I will remember for my life, because yes, this was one of those liftoff, those launch, I must say, which I will remember, because those HD views, those clear views, and those clear skies as such were so complimenting the today's views that everything frame by frame stored in my mind. So yeah. I do administration and a lot of medical, very far away from my chosen field. That happens. See, there is one thing which happens when we do engineering degree. And that is, I think, yes, it is valid globally that once you have engineering degree, you can do whatever. And most of the time this happens. Once you are in have an engineering degree, you will do something which is not related to engineering. Okay, you maybe after engineering you become a doctor, you become something else, but not an engineer. So mostly that happens for an engineer. So yeah. Okay then, guys, I think we can end this stream now. If you have anything else to discuss, feel free to chat, and we'll have a time to discuss. I'm always available for that. Otherwise, today's launch was a full success. We had a beautiful liftoff from the pad. Atlas 5 lifted off with this 4-to-1 configuration, which you can see here. Those RD-180 engines fired up to its full thrust, providing those beautiful looking plumes, complemented by those side solid rocket motors. And yes, when it is about to exceed the speed of sound, we get these beautiful Mach effects on the fairing, which we can see here. So the next launch is on 20th, and do join me for that. Otherwise, we can end this stream. Okay. I think there is no other thing to discuss. We can end this stream now. So until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and